properties of bulk matter. We have topic today. So we have first solid. So what is solid for you?
Which occupies space.
Okay.
It has
Anything
a
else?
hard structure.
Okay. So we have solid, which is a rigid body, which has a definite shape and size, right? From
Yes.
the in the smaller classes we have read that the solid something has definite shape and size. So I have a solid, for example, this one. So if I apply force to it, so is there any shape in change in shape or size?
No, ma'am.
No. Okay. If I apply large force, then there might
Yes,
something
it'll
happen to
break.
this pen.
It'll break.
Yeah, it will break. Or any there is a deformation, I can say that, right?
Yes, ma'am.
So I can't say the rigid body will definitely will have shape or size. Will we have their shape and size after I have applied the force? Okay. So in reality, when a force is applied on the solid object, so it is not compulsory. It will have the definite shape and size after the force applied. It can be deformed. Okay.
Yes, ma'am.
So this deformation we will study in the further topics. So the first topic is your elasticity. Okay. So have you heard about elasticity?
Yes, ma'am.
So what is elasticity to you?
Uh, Object which can stretch to its maximum.
Okay, stretch to its maximum. Okay, good. But when I release it, release my force. Okay, then what will happen?
Will come back to its original shape.
Okay. So the correct definition. So the correct definition is the property of a body by a virtue it tends to regain its original size and shape. Its original size and shape. Okay.
Yes, ma'am.
Any doubt till here? So
No, ma'am.
the simplest example we can take rubber. Okay, even we girls put on a rubber band. So what is that? I stretch to the maximum point, then I release the force, then the rubber comes back to its original
Yes.
position, right? So that is called, this property is called elasticity. Any doubt till here?
No, ma'am.
Okay. Before moving to stress and strain are the main topics of this chapter. We will do the three main, you can say the definitions. We should know that. So first is your deforming force. So what is deforming force? It is an external force that causes change in shape or size of the object. So what is happening? For example, I'm taking a rubber band. Easiest example I will take. So I'm stretching to a maximum, even more than a maximum point. So what will happen? Will there be a change in the shape of the rubber band?
Yes, ma'am. It
Yes.
becomes loose.
Yes, it will become loose, right? So that is your deforming force. So it is the external force that causes a change in shape or size. Any doubt in this?
No, ma'am.
Okay. When this force is applied, it can compress, stretch, or otherwise alter the object configuration. What is configuration?
The
Any in length, area,
structure.
volume. Any change in length, area, volume. Okay.
Yes, ma'am.
Okay. And the arrangement of its internal molecule. Example include stretching a rubber band or compressing a sponge with a force. Any doubt in the deforming force?
No, ma'am.
Again, let's move forward. So next we have perfectly elastic body. So what is perfectly elastic body? If I'm having a rubber band and if I stretch to a point and it comes back to its original shape and size, that is called your perfectly elastic body. Okay. So for the best example we have is quartz. So when I will apply the force on the quartz, what will happen? It will come back to its that original shape and size.
What is a
Okay.
quartz, ma'am? What?
Sorry.
What is a quartz?
It's quartz. It's kind of a material. Okay. So you stretch it to a position and come back to its original shape and size. It's an
Okay.
example of perfectly elastic body.
Okay, ma'am.
Okay. So next we have perfectly plastic body. So simplest example, I can take a bucket. Okay. So what will happen if I put a force on a bucket, a maximum, you can say a maximum force. So there be a kind of a dent on it.
Yes, ma'am.
Yes. So can we say it will not come to its original shape?
Yeah, it won't, ma'am.
Yeah. Yeah. So that is your perfectly plastic body.
Yes,
Okay.
ma'am.
So the perfectly plastic body is the one that does not regain its original position after the deforming force is removed, undergoing the permanent deformation.
Yes, ma'am.
Okay. Any doubt in the three
No, ma'am.
definitions? No. Let's move to the main. The question are asked from the stress. So have you read or any have knowledge about what is stress?
I know the formula, ma'am.
No worries, tell me.
Force by area.
Okay, force by area. So what's the pressure is also is equal to force upon area.
Yes.
So what is the difference between two?
I don't think there's a difference. Both are
Okay,
same.
there is no difference. There is a difference. What's your name?
Bhuvishka.
Bhuvishka. Okay, so there is a difference between two. So I have an object. I have a box. So I am putting a force on this area. That is your external force acting. So the
Yes.
internal force acting in at the, you can say, intermolecular. Okay, the internal force is acting internally. That's your stress. External is your pressure, and the internally the force per unit area is your stress.
Yes, ma'am.
Any doubt in now stress and pressure?
No, ma'am, not
Okay,
about it.
now you know the formula. So let me tell you the correct definition. So your stress, so you have correct definition. The internal restoring force acting per unit area. Acting per unit area. That is your correct definition of a stress. So you know what is stress? You said yourself only, that is your force upon area, right,
Yes.
Bhuvishka?
Yes, ma'am.
That, so what's the unit of stress?
Newton per meter square.
Newton per meter square, right? So I can write Newton or any other unit, you know.
No, ma'am.
Okay, that's your Pascal. Okay, or Newton per meter square, or NCGS unit.
Sieges. I don't know, ma'am.
Okay, so what is the CGS unit of the force?
Um.
No worries, that's your dyne. And
Okay.
what is the CGS unit of meter length? Sorry,
Length meters.
that is your centimeter. CGS unit of length is centimeter. So it
Okay.
will be dyne per centimeter square. Okay, okay, Bhuvishka. Bhuvishka, are you there? Hello, Bhuvishka. Hello, sir. Hello, hello. Sir, there was a black screen first, and then it was like left. Okay, okay.
Oh, yes. Sorry, ma'am. There's a power cut.
Sorry, sir. Yes, sir. So, Bushkash, the screen is visible to you?
Yes, ma'am.
Okay. So let's move forward. Where were we? So we were doing CGS unit of stress. Any doubt till here?
No, ma'am.
Okay. So let's move forward. Next, we have types of stress. So stress, we have different types of stress. We can see that is your normal stress. Normal stress is divided into longitudinal and volume stress, and that is again divided into compressive and tensile stress. So the first one we will discuss is the normal stress. Okay. So what is normal stress? When the deforming force act normally. So it is acting, I have a cylinder. So this is the force acting normally to the surface. Okay. That's your normal stress. Okay. Bhuvishka.
Yes, ma'am.
Okay. So it is of the two types. Already I have told you that they haven't written. It's okay. So it's of two types. First is your tensile. So what is tensile stress? Have you heard about it?
Yes, ma'am. Like, I should
Yes.
say it acts on the surface, like in the length, increases in length or something.
Okay, so you're right somewhat. So it's my what somewhat a cylinder, and I'm putting a force here. Okay, so I'm putting a force here. So what will happen? Will be increase in length, right?
Yes, ma'am.
So the stress acting here is your tensile stress. So tensile stress is the one where there is increase in
Length.
length. Okay, any doubt?
Yes, ma'am. No, ma'am.
Okay. Next is your compressive stress. Okay, so if I'm applying the force in this way, so my new length will be somewhat this,
Yes, ma'am.
right? So what will that is in decrease in length. Okay, compressive stress is the one when the I am applying the force normal to the surface. I am applying the force normal to the surface. There is decrease in length in the surface.
Yes, ma'am. Yeah.
Okay, so any doubt in these two?
No, ma'am. Got
Okay,
it.
your last one is your not last one. That's the third one. That is your hydraulic stress. So from the name, can you predict what is hydraulic stress?
Mm, is there water involved in this?
No, no, it's not about water, it's about volume. Okay.
Okay.
So if I'm having original volume, this V. Okay. So after applying stress, I'm applying stress from everywhere. Stress is applying. Okay. What
Decrease.
will happen?
Area will decrease.
No, bacha, volume will decrease. I'm talking
Okay.
about volume. Okay.
Okay.
So volume will decrease. This is my delta V. So where when applying the stress, sorry, I'm applying the force on the surface. So when the volume decreases, the stress is called hydraulic stress.
Okay.
Okay.
Yes,
Any
ma'am.
doubt in this one?
No, ma'am.
Okay. So last one we have your shearing or tangential stress. So what happens in the solid? Let me take another slide. So this is my last type, tangential or shearing stress.
Yes, ma'am.
Okay. So do you have any idea what is you know that what is tangent?
Yes, ma'am.
So what is tangent?
A line touching at one point of a circle.
Right, it's a touching point at the circle, right? So from here we can somewhat predict what it can be at an angle. For example, if I'm supposing this is my solid, okay, and
Yes.
here are my molecules, atoms, you can say atoms at the corners of the cube, and this is my intermolecular force between the atoms. Got it?
Yes, ma'am.
So everywhere. So after I'm applying the here your stress, okay, so what is happening there now, let me rub a little bit so can I can tell you. So what happens, Bhuvishka, there is a deformation at the angle, this theta. So where we see there is a change in the angle, okay,
Okay, ma'am.
if there is a change in the angle when I'm applying the force, there is a tangential or shearing stress.
Yes, ma'am.
Any doubt in the types? These are your four types. First is your normal, and under the normal category, you have two types. That is your tensile stress, and there is a compressive stress. Tensile is in there is increase in length, and compressive there is a
Decrease in volume.
very good. Second is your hydraulic stress. What is hydraulic stress?
It's, how should I say, decrease in length.
No, no, hydraulic. The name suggests hydraulic.
Volume.
Volume, right, very good. So there is a decrease in volume, right?
Volume.
So fourth is my type, tangential or shearing stress. So there will be change in
Change in volume.
angle, bacha,
Okay,
angle.
tangential. हाँ. Yes,
Okay,
ma'am.
angle. So from
Mhm.
tangent you can learn. From tangent you say na the circle, there is you line and draw a line. So here you say theta, theta here in both the sides, right? So from there you can learn this. You have your, there is a change in angle.
Angle.
Okay,
Yes.
any doubt is here?
No, ma'am. Got it.
Okay. So next we have very important, that's your strain. So tell me, have you any idea of strain?
Uh, no, ma'am.
Yes, Bhuvishka?
No, I have.
No
I'm
worries.
not.
So okay, I'm applying stress. Will something happen to it? Will you observe something different? Not this.
Oh,
If there is an elastic body, there is elastic, for example, rubber, and I'm implying the stress on it. So what will you observe?
mostly change in shape. It's elastic body.
Yeah, there will be a change in shape. So can I say there is a strain?
Yes, ma'am.
Yeah, in daily life we say na, there is a strain. Okay, you have this, listen, this word strain. So we will say that deformation on the object, that is your strain. Okay, so your
Yes,
strain is equal to your change in configuration. Configuration can be in length, volume, or area.
yes,
So
ma'am.
there will be a change in configuration over original configuration. Okay, so what will be its unit?
Newton meter square per meter square.
Bacha, that's stress, I'm talking about strain.
Isn't okay? There's no unit. And
No, there will be unitless. Why?
I'm not sure. That
Okay,
I know that they're dimensionless and unitless. I never
you
had it.
know, you don't know how.
Yes. I
No
don't know.
worries. So it's so the dimension comes from the formula itself. Okay, so in the earlier we had the formula, stress is equal to force upon area. What is the unit of force? That we know, Newton. That is your area. We know what is the SI unit of area, Bhuvishka?
So unit uh
Unit of area, simple unit of area.
meters.
Unit of length.
In unit of length is meters.
And what is area? Length into length,
Yes, ma'am.
meter into meter,
Meter square. Okay.
meter square, right? So that's why written meter square. So the unit is coming from the formula.
Yes, ma'am.
Okay, got it? Wait a second. Yeah. So from here, I said the strain is your change in configuration upon original configuration. So you can see how it is unitless from the formula. So change in, there is a unit of change in configuration. For example, if I'm taking, you will read the first step is your longitudinal. So first is your Bhuvishka is a longitudinal strain. So it is your change in length over original length.
Yes, ma'am.
Got it? So what will be unit of my longitudinal strain?
Length means we can't tell the delta L. So mostly it's meter.
It's meter, right? So what is the
Meter by
unit of meter? So meter
meter.
and meter is cancelled out. It will be unitless. From here it came the unitless. Say in the same way, change in configuration. It is also configuration. It is also all configuration. So they will cancel it out. That's why its unit is unitless.
Yes, ma'am.
Got it? So the
Yes,
units come in the, even in you're in 11th class. In the first chapter is your units and dimension.
yes, ma'am.
Okay, in that only you have read about units, how the units are derived. So many maximum units, the basic units have meter, seconds, kilogram, and you use them and find the units of different quantities. You have force, energy, density, even the velocity. So you find the all the units from the formula.
Yes, ma'am.
Okay, got it? So from this also came from the formula. Okay, any doubt till here?
No, ma'am. Got it.
Okay. Wait a second. So your first type of strain is longitudinal strain, that I told you, that is change in length over original length. Any doubt in this longitudinal?
No, ma'am. Got.
Okay. Second is your volumetric strain. So what is volumetric strain? You can predict from the,
Change in volume.
yeah, right, very good. So change in volume over original volume. Any doubt in this?
No, ma'am.
So what will be unit of volumetric strain?
No unit.
No unit, right, very good. So I just asked you if you are confident about your concept or not. Okay.
Okay, yes,
So
ma'am.
third one is your tangential strain. So you know what is tangential stress? That is acting when there is a change in angle, right?
Yeah.
So in the same way, when there is a change in the dimension at the angle, that is your tangential strain. There is no formula of that. There is only a definition of it. Any
Okay.
doubt in this?
No, ma'am.
Okay. So next topic we have your Hooke's law. Do you know Hooke's law? Very, very, very important. Favorite question.
No, ma'am, I don't know.
Okay, no worries. Let me tell you. So what does it say? Let me write the statement first. It states that the extension produced in the wire is directly proportional to the load applied within the elastic limit. So what it is saying, basically in one line I can say that it is saying that stress is directly proportional to the strain,
Okay.
in simple line. Come to the statement. The extension is your strain,
Mm.
okay, produced in the wire is directly proportional to the load. What is load? That is your stress.
Stress applied.
Okay, you are putting a load, that is you're putting a stress. Okay,
Yes,
so
ma'am.
extension means that is it is a producing a strain, so both are directly proportional to each other. Okay,
Yes, ma'am.
so to remove the proportionality constant, what do I do?
Take a constant.
Okay, remove and
Put
put a
constant.
constant, and that constant is called modulus of elasticity.
Oh, okay.
Okay, and E is called modulus of
Elasticity.
elasticity. Any doubt till here?
No, ma'am.
Okay, so can I write E is equal to strain up, sorry, I did a bit mistake. It's stress here. So here is stress is equal to E is equal to strain. So can I write um, E is equal to stress upon strain?
Yes, ma'am.
So what is the unit of E?
Newton meter square, not per meter.
Newton?
Meter square.
Why meter square?
Much.
Because stress is equal to force upon area. So why Newton meter square?
And into strain, like divided by strain.
We know that the unit of strain is unitless. This is unitless, right?
Yes, ma'am.
So
So
what
in
is the unit of stress?
Newton per meter square.
Per meter square. Don't get confused. It's
Okay.
easy. Okay, no worries. So you can also write Pascal. So this is the unit of modulus of elasticity. Any doubt?
No, ma'am.
Okay. So what will be the graph between stress and strain?
I don't know. A straight line.
So sorry.
A straight line.
Yeah, straight,
One.
right. So you have stress, here is strain. We know that you're directly proportional. When there is a, you have read in the maths too, y is directly proportional to this. So the graph between the y and x will be your straight line. Okay. So the graph between it will be start from a region. So the graph between the stress and strain will be a straight line. Okay. Any
Yes.
doubt till here?
No, ma'am.
Okay. Let's move forward to the types of elasticity. So first type of your modulus of elasticity is Young's modulus. Okay. So what is Young's modulus? Y is equal to, it is denoted by Y. It's normal stress upon longitudinal strain. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Okay, sir.
Okay.
Thank you.